Hi, in today's video, we'll have a look at multicollinearity and how it can arise when you run a linear regression. So let's start with the problem of exact multicollinearity. The issue of exact multicollinearity arises when you include in your model two or more explanatory variables for which there exists a perfectly linear relationship. Right, so let's consider the following regression model. So we have weight as our dependent variable, and we include as regressors height in centimeters, and then feet and inches. Okay, so the model is weight is equal to alpha, our intercept, plus beta 1 times height, plus beta 2 times feet, plus beta 3 times inches. So the intuition behind this regression is that we want to see the relationship between someone's height and their weight. Now, one thing that we do know is that if height is in centimeters, the way you can convert feet and inches into centimeters is by the following equation. So height in centimeters is equal to 30.48 times feet plus 2.54 times inches. So that is a linear relationship, a perfect linear relationship between one of the regressors that we had, which was height, and two of the other regressors, so feet and inches, right? So whenever that happens, the model cannot be estimated, and we need to exclude at least one variable, okay? So that's something that very often your regression software will tell you, and it will automatically exclude one of the variables. So then it's the problem of exact multicollinearity. And usually there's something that is relatively easy to avoid. And when you see that your software has excluded some variables, that is always a problem of multicollinearity, and you can figure out what the problem is. But there's another problem that can crop up that can actually be a little bit harder to realize, and that's just the problem of multicollinearity. And that's when you include in your model two or more explanatory variables which are highly correlated. So this time around, they're not perfectly correlated, but they're just highly correlated. So let's consider the following regression model. So in basically prison, for prisoners over 50. So we have weight is equal to alpha plus beta 1 times height in centimeters, plus beta 2 times feet, plus beta 3 times age, plus my error term. Now, notice here that we only include feet and we no longer include inches. So the results from this regression is that beta 1 is equal to 2.025, beta 2 is equal to minus 0.8.8, and beta 3 is equal to minus 0.2. So here we see that we do get results when we run this regression. So the statistical software will not give out any warning, it will run it without any problems. But now the regression results will not necessarily make any intuitive sense due to that multicollinearity issue. Okay, so here, if I look at my coefficient beta 1, that would mean that the 1 centimeter increase in height is associated with a 2.02 unit increase in weight. And if I look at beta 2, it would say that a 1 foot increase in height is associated with a minus 8.8 unit decrease in weight. So clearly that seems contradictory because in one case, height seems positively correlated with weight, and in the other case, height seems to be negatively correlated with weight. So here the problem is relatively simple to see. So we included height in centimeters, but also another way to measure height, this time in feet. And so both variables measure, broadly speaking, the same thing. So that's the main issue that we have in our regression. And that's why we get nonsensical results. And what we could do to deal with this issue is to simply exclude either height or inches from the regression. And if we exclude height, we get this. So y is equal to alpha plus beta 1 times feet plus beta 2 times h plus ui. And we get a beta 1 that is positive, and it's 24.49. Now, if we include inches, then we get weight is equal to alpha plus beta 1 times height plus beta 2 times h plus ui. And now we get a beta 1 that is 1.86. And in this case, both show that there's a positive correlation between height and weight, irrespective of the measurement that you use. So that's actually a problem that you can come across in regression, especially if you add a lot of regressors in your regression. Sometimes you will see patterns that seem counterintuitive, or you will see that your standard errors are very large, and that could be caused by multicollinearity. So that's it for today's video, and I'll see you in the next one.